Top 10 Natural Gemstone Colors. You won't believe exist. Nature doesn't need to be manipulated to amaze, especially when it comes to color and gemstones. Some rare stones don't just sparkle, they display colors that are so illogical, but they're entirely natural and untouched by humans. These effects aren't the result of treatment techniques, but are genuine optical phenomena created by the crystal structure. This video explores 10 of the rarest and most unexpected colors ever recorded in the gemstone world, each a testament to the wonder of the earth that transcends the limits of vision. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Ranked 10th, Ammolite, the fossil that looks artificial. At first glance, it seems impossible. A fossilized surface radiating with vivid colors, metallic reds, neon greens, electric blues, flashes of violet and gold, looks digitally enhanced. But this isn't CGI. It's Ammolite, a natural gemstone forged from the fossilized shells of ancient sea creatures called ammonites, dating back 70 million years. The color comes from nature's nanotechnology. Unlike opal, whose play of color is due to microscopic silica spheres, Ammolite's iridescence is caused by ultra-thin aragonite layers, some just 0.00003 inches thick. These layers diffract light like a film of oil on water, splitting it into pure spectral colors. The effect is so intense that some specimens can display all 7 rainbow colors in a single light sweep. Every Ammolite is unique. No 2 patterns repeat. Some ripple like flames, others shimmer like snakeskin or dragon scales. Under different angles, the colors shift and pulse, alive in a way no other gemstone can replicate. Ammolite is found almost exclusively in southern Alberta, Canada, where prehistoric inland seas once thrived. While it ranks only 4.5 to 5.5 on the Mohs scale, gem-grade pieces are often stabilized and set into pendants, brooches, and collector's items. High-quality stones with full-spectrum color can command between $500 and $1,500 per carat. Of all natural gemstone colors on Earth, few are as unbelievable and biologically ancient as Ammolite. It's not just beautiful, it's prehistoric light, refracted through time. Ranked 9th, Grandidierite, ice blue-green with yellow shift. In the southern highlands of Madagascar, near the windswept cliffs of Andromeda, mineralogists once unearthed a translucent stone that defied classification. Its color hovered between sea glass blue and mint green, but a fleeting yellow undertone emerged as light refracted through its crystalline layers, calm, subtle, and unmistakably natural. This phenomenon, known as trichroism, is one of the rarest optical properties in the gem world. The stone was named Grandidierite after French naturalist Alfred Grandidier, who first studied Madagascar's geology in the early 1900s. For decades, Grandidierite remained an academic curiosity, too opaque for cutting, too scarce for commercial mining. Only a handful of translucent specimens existed, housed in institutional collections, and often misclassified as other beryl-type minerals. That changed in 2014 when a new deposit in Tranamaro revealed gem-quality crystals with visible clarity and trichroic behavior. The reaction from the gemological world was immediate, not because of size or brilliance, but because no other known stone offered the same ice blue-green core with golden undertones, without any treatment, diffusion, or heat. With a hardness of 7.5 on the Mohs scale, Grandidierite is suitable for high-end jewelry, though stones over 1 carat remain exceptionally rare. Top-grade material, driven by color and sheer geological improbability, can reach $20,000 to $30,000 per carat. No synthetic imitation can reproduce the complete spectral shift of Grandidierite. This gem stands apart in a market saturated with exaggerated hues and enhancements, a whisper of polar light captured in mineral form, seen only by those who know where to look. Ranked 8th, Peacock Tanzanite, multicolor trichroism. Some gems sparkle, others that glow, but Peacock Tanzanite doesn't behave. It transforms. As the stone turns, so does the light within it, shifting from deep indigo to royal violet, then catching a streak of crimson at the edge, like a candle behind stained glass. This is no ordinary tanzanite. It's a rare, untreated crystal exhibiting full trichroism, the ability to show three distinct colors depending on angle and light. This optical display is so astonishing that it exists naturally, without enhancement. Most tanzanites on the market are heat-treated to favor blue tones and mute the rest, but a select few emerge from the earth, already vivid and multidimensional. Their colors don't just appear, they interact, flowing across facets in liquid motion. There is no dye, no diffusion, just the natural dance of crystal and color. These gems are cut not for brilliance, but for balance. Only specific orientations preserve the whole spectrum. The finest examples display blue, violet, and pink-red, all in a single turn, each hue pure, visible, and independently alive. Most specimens fall below 3 carats, yet their scarcity and visual complexity push prices upward of $1,500 per carat. Peacock Tanzanite remains a defiant anomaly in a marketplace saturated with artificial color and synthetic sparkle. It doesn't imitate fire, it whispers in cool tones. It is a stone that doesn't reflect what's around it, but what might be hidden just beneath the surface of light itself. Ranked 7th, blue amber, golden indoors, electric blue outdoors. By lamp, it appears warm, deep honey with soft golden undertones, like fossilized sunlight trapped in resin. But under the open sky, the illusion fades. Exposed to ultraviolet rays or direct sunlight, the entire surface ignites with an electric blue glow that looks synthetic, almost surreal. Blue amber is one of the rarest forms of natural amber ever discovered. Blue amber's spectral effect comes from a rare compound interaction. Thought to originate from the extinct leguminous tree, Hymenaea prodera, the resin underwent fossilization in oxygen-poor environments rich in hydrocarbons. Over time, these compounds altered their surface structure just enough to produce a natural fluorescence that reflects blue light with astonishing clarity. This phenomenon is not universal across all blue amber. Only specimens from specific regions of the Dominican Republic and parts of Sumatra exhibit the intense UV reactive glow. The optical effect, not pigment-based, disappears under artificial indoor lighting. Under natural light, however, the stone appears to radiate from within. On the Mohs scale, amber ranks 2 to 2.5, making it one of the softest organic gemstones and suitable mainly for pendants and brooches. Yet despite its fragility, high-grade blue amber can fetch $300 to $1,200 per carat, particularly when the fluorescence is intense and evenly distributed. Blue amber defies visual logic. It's a gem that changes not with the hand that turns it, but with the sky above it. A stone that glows not for the eye but for the sun. Ranked 6th, Trapiche Emerald. Starburst growth in green. Geometry and symmetry are rare in nature, yet deep within the emerald fields of Colombia, a gemstone forms with such mathematical precision that it appears artificial. Its deep green body is divided by dark spokes radiating from a central core, like the wheel of a cosmic machine. This is the Trapiche Emerald, a gem where crystal meets compass. The name trapiche comes from the Spanish word for a sugar mill's grinding wheel, echoing the gem's 6-point radial pattern. But this structure isn't a surface feature or carved detail. It is natural crystal zoning, formed when carbon impurities intersect with emerald growth along the hexagonal axis. The result is a gemstone that carries within it a starburst, dark rays of black shale or albite slicing through rich green beryl. Not all emeralds grow this way. The conditions must be exact: slow crystallization, high pressure, and mineral interruptions along symmetrical planes. Only the Muzo and Chivor mines of Colombia consistently yield trapiche material, and even then, most stones are incomplete or unsuitable for faceting. Despite being less transparent than gem-grade emeralds, trapiche emeralds are sought after for their rarity and structure. Collectors prize stones that display clean, centered 6-ray formations. Values vary widely, but fine specimens above 1 inch in diameter can command $5,000 to $15,000, depending on the definition and intensity of green. The Trapiche Emerald is not prized for brilliance, but for its design authored by nature itself. A gemstone that captures light and reflects symmetry from the atomic to the spiritual. Ranked 5th, Paraíba Tourmaline, neon blue from within. Most gems reflect light. This one generates its own. The glow of Paraíba Tourmaline doesn't shimmer softly. It pulses, electric and unrelenting, like a neon filament suspended in crystal. Its color, a piercing blue-green, unlike anything seen before 1989, is not simply rare. It is geologically improbable. Trace amounts of copper and manganese, elements rarely found together in tourmaline, cause the effect. These impurities replace atoms within the crystal lattice, producing a unique chromophore that absorbs selectively across the visible spectrum. The result is a gemstone emitting a luminous, high-saturation hue, visible even in low light, a quality gemologists call day-glow intensity. The first stones emerged from a hillside in Paraíba State, Brazil, where miner Hader Barbosa spent years digging into what others believed was barren ground. The rocks he unearthed, often under 3 carats and riddled with inclusions, shocked the global gem market. No one had ever seen a natural tourmaline radiate color like this. Demand soared, and the original mine was depleted within a decade. Today, similar copper-bearing tourmalines are found in Nigeria and Mozambique, but collectors continue to differentiate between Brazilian Paraíba and African Paraíba, with Brazilian origin commanding the highest prices. Fine stones exceeding 5 carats can reach $50,000 to $100,000 per carat, depending on saturation and provenance. Paraíba tourmaline is a stone that rewrote expectations of color, chemistry, and rarity. Unlike most gems, it doesn't rely on fire or facetting. Its power lies within. It is not just a jewel, but a surge of color embedded in stone. Ranked 4th, color change garnet, green to red optical shift. What appears green under the sun turns crimson beneath candlelight. One stone, 2 worlds. The phenomenon isn't surface deep or lighting trickery. It's an intrinsic shift in how the stone absorbs and reflects wavelengths. This is the elusive color change garnet, a gem that exists in a constant state of optical negotiation. The effect is caused by a unique blend of spessartine and pyrope garnet groups, with vanadium and chromium acting as chromophores. In daylight, these trace elements allow for the reflection of cool greens and blue-greens. Under incandescent or warm artificial lighting, those elements shift their response, emitting deep reddish to purplish hues. The transition is not gradual. It is immediate and complete, often catching viewers off guard. What makes color change garnet remarkable is the strength of its dual identity and the fact that both colors are desirable. Some gemstones change from one dull tone to another. Depending on the specimen, this variety moves between 2 vivid poles: forest green and wine red, teal and raspberry, moss and flame. Stones with a high percentage of change, over 90%, are considered top tier. Sources include Tanzania, Sri Lanka, and Madagascar, though only a small percentage of mined garnets exhibit substantial color change. Most cut stones fall between 0.5 and 2 carats, with fine specimens ranging from $1,000 to $3,000 per carat. Larger gems with strong chromatic contrast can exceed $10,000 per carat. Color change garnet doesn't imitate alexandrite, it rivals it. A stone that embodies contrast not as conflict but as duality. A gem that doesn't reflect what it is, but what surrounds it. Ranked 3rd, Rainbow Lattice Sunstone, geometric iridescence. At the microscopic level, most gemstones are chaos, fractures, clouds, and disordered growth. But one stone defies that norm with uncanny symmetry. Inside a translucent feldspar body, rainbow-colored lattices crisscross like holographic scaffolding. Straight lines, angular precision. Yet every ray of color bends like oil across the water. This is Rainbow Lattice Sunstone, a geological paradox that unites structure with shimmer. Discovered exclusively in the mud tank zircon field of Australia's Northern Territory, this gem contains inclusions of hematite and magnetite suspended in perfect geometric arrays. These metallic platelets form at precise angles during cooling, creating an optical effect that splits light into vivid purples, greens, golds, and blues, often simultaneously. What's extraordinary is the iridescence in its pattern, a natural diffraction grating born inside a volcanic rock. Each specimen is a fingerprint. Some reveal intersecting lines like spider silk under stress. Others scatter the lattice into hexagonal auras or shimmering prisms. The visual result has no digital equivalent. Photos flatten it, videos dull it. Under shifting light, the gem only exposes its whole symphony of angles and spectrum in motion. Though it registers 6 to 6.5 on the Mohs scale, rainbow lattice sunstone is rarely faceted. Most are cut into domed cabochons to preserve surface tension and maximize visual complexity. Top-quality stones with saturated body color and dense lattice formations can reach $500 to $2,500 per carat, though collectors and avant-garde designers dominate their market. In a realm where most gems seduce with color or clarity, this one mesmerizes with patterned light. A stone that speaks not in sparkle but in symmetry. Ranked second, black opal. Rainbow fire in a midnight body. No other gemstone captures color quite like black opal. Its surface doesn't reflect, it performs. Against a deep inky background, flashes of spectral color ignite in a chaotic rhythm. Neon green darting beside electric crimson, followed by bursts of gold, violet, and cyan. Each movement of light across the stone's dome reveals a new arrangement. No two glances return the same pattern. Opalescence gives black opal its hypnotic glow. It is caused by an internal structure of microscopic silica spheres stacked in grid-like formations, diffracting light into full-spectrum fire. In black opal, the contrast is enhanced by a dark iron oxide body tone, making the colors appear more saturated, almost animated. This interplay, depth versus brilliance, separates black opal from all other opal types. Mined almost exclusively in Lightning Ridge, New South Wales, Australia, black opal is rare for its beauty and the geological precision required to form it. The conditions must balance silica concentration, groundwater chemistry, and time in the range of 5 to 20 million years. Even then, less than 5% of mined material qualifies as gem grade. Top specimens, free of cracks and with strong play of color across the entire surface, can command $5,000 to $50,000 per carat, especially those displaying red or multi-directional flash. Stones over 3 carats with full spectrum color are auction-level rarities. Black opal is not a stone of subtlety. It is a gemstone of spectacle, a fusion of darkness and fire, where color doesn't sit on the surface but rises from within. In the first place, Chameleon Diamond, a diamond that changes color. It defies the very principle that diamonds represent, permanence. Known for their unchanging brilliance, diamonds are prized for stability, fire, and clarity. But one rare type does the unthinkable. It changes. In darkness, it appears olive green, sometimes grayish, but under heat or ultraviolet light, it shifts, temporarily, into yellow, chartreuse, even burnt amber. This is the Chameleon Diamond, a gem that does not sparkle in defiance of time, but in defiance of identity. The phenomenon is not superficial. It's not a coating, trick lighting, or treatment. It is embedded within the crystal's atomic lattice. Scientists suspect the cause lies in unstable defects and the presence of hydrogen, nitrogen, and vacancy clusters, which temporarily rearrange under specific thermal or photonic conditions. The color change is reversible, consistent, and completely natural. No other diamond, indeed no other gemstone, behaves in quite the same way. Chameleon diamonds are so rare that fewer than a few hundred have been thoroughly documented worldwide. Most weigh under 1 carat, though a handful of large stones have emerged from African deposits, particularly in Sierra Leone and the Congo. When available, they are prized for carat weight or clarity and responsiveness, the speed and intensity of their transformation. High-quality specimens can fetch $20,000 to $100,000 per carat, depending on origin, size, and color range. To collectors, chameleon diamonds represent more than beauty. They embody contradiction, strength that flexes, brilliance that adapts, and identity that refuses to stay fixed. At the pinnacle of this list It's not just color that astonishes. It's the idea that even the world's hardest gemstone can evolve. Some colors are rare, others are impossible. But even the impossible has a place in the world of natural gemstones. These stones are not only beautiful, but they also challenge what we think nature can do. With each flash, change, or geometric sparkle, they reveal that the Earth does not play by our rules. The Earth invents its own rules. What is most amazing is that many of these gems were once overlooked, misidentified, or buried under layers of dust in forgotten drawers. Across deserts, in ancient caves, beneath oceans and volcanic vents, new stones, new colors, and new mysteries are waiting to be unearthed. Let us know which resonates with you in the comments, and don't forget to like and subscribe to our channel for more content like this.